So you have the data, the participant has given you the consent. How do you get this data to be used, to be processed, to be analyzed, so that it can then be used for policy making? And there are 4 things here that I have mentioned. One is that you have to use secure channels. Secure channels here, I started by talking about issues of technology. WhatsApp, social media, how do you ensure that data you use, the secure channels are used when transmitting the data? Because somebody can just post the data set to me on my WhatsApp. My WhatsApp, may not be that secure. It may be secure to me, but I'm not so sure if maybe some other people may access my WhatsApp. How do you ensure that happens? So you may always make sure that you use only secure channels for transmitting this data. And this can be, synchronizing, because we collect data electronically now. So you submit the data using the electronic gadgets, sometimes encrypted. And the data systems developers, actually, there are a lot of advances around encrypting data when being transmitted from one level to another, so that to prevent any unauthorized access or interceptions, and maintaining some data integrity. I was in an institution actually before that actually it prohibited sharing data on email. So that's also another consideration. Is email secure? So it may depend. It may be or it may not be. So those are conversations that need to happen. Data integrity. When you're transmitting data, implement measures to validate data accuracy and integrity during transmission. So this one will obviously help you to minimize the risk of corruption or loss. Data transmission timelines. When you have collected the data, is in your tablet as a field interviewer, and then it stays in the tablet, and you're moving with that tablet from the field to your house, and maybe it's a weekend. You have gone to, you have gone to a social function, and maybe there is a temptation to use the tablet because it is, it can have maybe good camera. You use the tablet for camera, taking the the photos in the social function, and the data is also somewhere in the tablet. These photos, your friends also want to see the photos that you have taken, and they borrow your tablet. Already the tablet now is in an authorized hand. How do you ensure that unauthorized hand that has the tablet and has very sensitive mental health data in the tablet, that they don't have access to that? Because the tablet may disappear, it may break down, and there may be so many things that may be associated with that device that you're using to collect the data, and you may end up losing the data. Can you imagine? You have invested $1 million to collect data, and then that data gets lost because data were not transmitted in a timely fashion. Those are things that may, these kind of standards and practices and processes and data governance measures are put in place to minimize loss that may happen in such a way. Keep track of daily submissions. And this one also, of course, helps to ensure that when I know that 20 interviews were conducted on, in a mental health study in a day, that in the server, I have 20. If in the event that 20 were collected in the field, but I only have 15, then I need to ask myself, where are the other 5? And so there needs to be that kind of daily check of these transmissions. Right, so the data have come. So of course, the data management plan, it's important. We talked about this for clinical trials, and for clinical trials, it's important to do good clinical practice tests, and actually some ethics require that you do that for clinical trials. Standard operating procedures for the different things, for data entry, for data transmission. So those are 2 different standard operating procedures. There could be also standard operating procedures around how to collect laboratory information. how to handle, samples in the case of clean, if you are collecting blood samples, then how do you manage that? How do you make sure that there's linkage, good linkage and data linkage between different sources of data? It's very important. So validation of the data, check all data for errors, completeness, and consistency. This is important because it helps to capture any issues before analysis, so that you use very accurate data for analysis, and it will give us quality evidence. There's also a process called data documentation. I think it's coming up in the next slide. But I've talked about anonymization, and I want to differentiate here between anonymization and de-identification. So what is commonly done is de-identification. So de-identification is where you remove what we call personal information, personal identifiable information. This could be names, could be things that can be used to identify an individual in a data set. So those ones are stripped, but the data set still has a link, has another variable that can be linked back to the personal data, So you have a de-identified data set, doesn't have personal identifiable information, but it has an ID, let's say PID, a personal ID, a pseudonym, that is unique to every individual. So that's the identified. But anonymized data is where you have a data set that you cannot, given that data set itself, you cannot in any way link back the information in that data set to any individual person. That is the data set that's okay to be shared openly, like in an open access kind of framework. Anonymized data. And so it's important to always have this kind of anonymization techniques trained to the people handling the data. And there are so many right now advanced anonymization techniques, which I may not have the time to discuss because it may take time. I just mentioned a few. So there's one that is very common called K-anonymity. K-anonymization technique. And that is the most common actually that is used right now to ensure that the data is anonymized. And the reason why it has to be fully anonymized and actually conduct sensitivity analysis to ensure it's anonymized and there's no information that is lost is because there are studies that have shown that actually it is possible to still identify people or individuals through variables that are not what we call personal identifiable information. A variable like sex and age and date of birth. So this, if you just have them, you may not really know if this date of birth belongs to who. But there are some advances actually in AI that are actually making it possible to still re-identify people using these kind of variables that are not traditionally known as personal identifiable information. In fact, they are now called quasi-identifiable data, quasi-identifiable variables or information. And in my next slide, I'm going to show you some report that actually was found several years ago. I think I've already talked about this. Audit trails, ensuring that you maintain a very good record of the data processing steps, transparency and accountability steps, so that you have very documented way. If you change a variable from 10 to 20, what informed that change, so that in case that was an error, then we can still be able to go back to the original data set. Now, this is the report. In 2000, the US Census was conducted. United States Census was conducted. And there's somebody who conducted a privacy study called Sweeney, and it was published in the, I think, Carnegie Mellon University, data privacy paper. Now, take note of the area that I've highlighted in yellow. It was found that 87% of the individuals in the United States had reported information like, zip code. It can be the address, sex or the gender, and the date of birth. Now, this study found that with this information, the address, the zip code, the gender, and the date of birth actually enabled this researcher to uniquely identify 87% of the individuals in the United States. Now, if you just add another variable, maybe we can call it, just look for another variable and to add to this. So there's no name, there's no GPS there, it's just quasi-identifiable information. If we added another variable, I think you could actually identify way more participants. And this actually brought the conversation around this quasi-identifiable information and coming up with more advanced anonymization techniques like the K-anonymization technique. So I talked about data documentation. So of course, after you've collected your data, you have your data you've analyzed, you've anonymized, and all this. It's important to have a documentation of this data because we are talking about reuse. We are talking about use and reuse of data. We are talking about repurposing of data. We're talking about sharing this data openly. When you have a data set that has 10 variables, X, Y, Z, without information telling us what X is and what Y is, what Z is, that data may not be useful. And so data sets that are shared openly for secondary use, they must be accompanied by very clear documentation of this data. Now, the documentation involves several things. One is documenting the processes that happened, sharing the study protocol, metadata, which is both human and machine readable, data dictionaries and code books, just to describe the different variables and the levels of measurement for the different variables. If you have sex coded 1, 2 or coded 1, 0, yes, no, coded 1, 2 or coded 1, 0. So it has to be clear. If it is longitudinal, then it's consistent. Which questions were introduced where, which questions were dropped where, which questions were consistent. All that documentation needs to happen. And if you need to upload this data to a public repository, then you also have to adhere to the data sharing policies for that institution and also for the country. And it's also very important. So we make sure the data are anonymized completely before sharing it to a public repository. So this is key component for data reusability. I talked about and reproducibility of findings, because like, for example, many journals now, I remember like PLOS, I think you have to, when you submit a paper, you have to submit together with the data that are used to generate the findings in that paper. Now, for data reuse and for decision making, so the key thing really is that you need to use quality data for analysis, so that you have quality evidence for decision making. Leverage data insights to make informed decisions that are grounded on empirical evidence and mostly latest evidence as much as possible. And leverage on the available data science technologies now that we have, visual analytics that will make data to be available in a format that is more understood, in a format that is easy to use, interactive format, that somebody who is interacting with this data doesn't have to read a 30-page report. They can just look at, very, very snapshots of key evidence or key findings, in a visual format. And that will make the use of evidence faster. It will make the use of evidence easier. and ensure that and there are so many: Power BI, Tableau, R/Shiny for the people who use Python. There are many ways that you can actually use these modern tools. Use data that is structured. Ensure the data is structured and documented according to the FAIR principles. Lillian already introduced what FAIR is: data that are findable, accessible, interoperable, and reusable, so that it enables its easier discovery and reuse by others.